Welcome to Java JSM, and in this video we are going to talk about time complexity and space complexity. The most of the times the peoples are confused, whatever the beginners or whatever the experienced peoples are so confused, like how to calculate the time complexity, how to calculate the space complexity. But the problem is when you go and give the interview of any big product based company, then definitely they will ask you whatever the code you have written, what is the time complexity and what is the space complexity. So you have to calculate the space complexity and time complexity for your particular code. Okay, so for that I am going to suggest you like how you can calculate the time complexity and space complexity and what is the role of that in your programs. Okay, each and everything we are going to discuss in this video. So let's start now. So basically the time complexity and space complexity. Before going to do anything, let me ask one question. The question is in front of you only. Is the time complexity of a algorithm or code the same as the running execution time of the code? Tell me. Whatever the time complexity algorithm are saying, whatever the based on your code, is that the same as running or executions of the time of your code? Exactly no. Absolutely no. Because time executions, whatever the code you are running in your system, it's depend on your processors. What are the memory you are using? You are using the RAM, you are using the SSD. Based on that capacity it will perform the running executions time. But what is the time complexity of code based on the algorithm, that is not decide with the running executions time. Totally both are the different. Okay, both are the totally different. Might be, let's take one example. For example, if I say we have written one code, the time complexity of the code is n square or chai n. Okay, and the same code if you go and if you run inside the Windows, it will run in like 0.2 milliseconds. If you go and run this the same code in the Mac, maybe it will fast, so 0.1 second it will do. If you go and run in any Linux systems, then maybe they will run 0.6 or 0.5. Sometimes what will happen, if you run the same program multiple time in the same system, that time also it will give the different type of the running executions time. So it's happened. Okay, so don't worry about the running executions time. Okay, only focus like what is the code, and based on the time complexity of algorithm, space complexity of algorithm, we can calculate it. We can't calculate based on the running executions time. Clear? Okay, so this is the one clarity I have to tell you guys. So like so many people are confused based on that. Take one example. We have a one room as a classroom, and inside the classroom having 100 people, 100 students you can say, and you have given your pen to write the like do the signatures on the papers. So you have done the signatures and you pass those pen to the some other peoples. Okay, other peoples are also doing the signatures on the papers. Okay, so slowly the pen will distributed in 100 peoples. Okay, it will happen generally. So what will happen is suddenly after 5 minutes or 10 minutes you started searching like where is my pen, you want your pen now. So you started searching. So what you can do, while starting a searching, you ask some peoples, hey, did you see my pen? He will tell no. So it will like okay, can you ask some other peoples and also tell him to ask some other peoples. So what will happen is here I ask with someone, someone ask with someone, someone ask with someone, and I am also parallelly asking some other people also. So what will happen? In the same way, it will go and ask with multiple peoples at the one peoples will ask with the all those peoples, one peoples will ask with the all those peoples. So that time if you consider some of the time complexity like n square, if I only one peoples and I started asking with everyone one by one, that is called n square. So I hope those things like order of n, big O of n, omega of n, theta of n, all those things I hope you know. Okay, through that we are considering, but let's understand in the depth like what we can say, like why we are considering order of n, why we are considering theta of n, big O of n, all those things. Okay, so let's start now. So if you see here the time complexity of a algorithms, if you see here the time complexity of algorithm or code is not equal to the actual time required to the executions of a particular code. So whatever the code you have written, that is not same as the time complexity of algorithm you calculated is equal to your execution time. That I hope you understood. Okay, but the number of times a statement execute we can prove this way to using a time command. So with the help of the time command we have, so through that we can display the time, like how many times it will take to display this output and how many times to take this display to this output. So based on that we can just get some almost idea, like okay, this is running that much time, this is running that much time, but we can't find out the exactly. Okay, for example, write a code in C or C++ or Java, any other language, to find the maximum between n numbers. Okay, for example, we have a 10 numbers. In 10 numbers, we have to find out which number is the maximum numbers. For that, we have to iterate one loop and check with everyone who is the maximum. Like that, we can find out. So where n is the various form, maybe the 10, 100, 1000 or 10,000 it's happen. So we will get surprising result is n equal to 10. You may get 0.5 milliseconds time. For n equal to 10,000 you may get 0.2 milliseconds times. Okay, as you will get different timings of the different machines, even if you will not get the same timings on the same machine for the same code. The reason behind that is the current network load. Okay, so whenever you are running the code on your system, so sometimes the load is high of the particular system, so because of that also we are facing the issue. Okay, let's talk about some other points. So we can say that the actual time required to execute code is a machine dependent. Okay, so whatever the code we are running on the system, that is depend on the machine, not in our code. Okay, and whether you are using a platinum 1, platinum 5, and also consider the network load for your machine LAN or WAN, whatever you are using, based on that only it will calculate the time complexity. I hope it's clear. Okay, so once you understood how we are calculating the time complexity, let's understand what is meant by the time complexity of an algorithm. And now the question arises, if the time complexity is not the actual time required to the execution of the code, then what is it? Then why we are calculating it? Maybe the person will ask. Okay, like if the execution time is not equal to the time complexity, whatever the algorithm we were calculating, then what is the use of it? Then you can say them, hey, instead of measuring a actual time required in the execution each statement in one code, the time complexity consider how many times each statement execute. So basically we are not going inside the depth and we are considering each and everything, but we are considering as a one unit time complexity in one of the unit, and through that we are taking, like if one statement one time execution will happen, if two times 2, 3, 3, 4, 5, 6, like that we can consider it. Okay, let's go. So what I'm going to do is I'm going to tell you like how we can consider whatever the time complexity we have and how we can work with that. Okay, So let me go to my notepad. Okay, so basically if I talk about time complexity, okay, so time complexity is there is a different units we have, and based on that unit we can calculate the time complexity. For example, if you see here, let me show you. We have a one big O annotations. If you see here, we have a big O annotations. So big O annotations we can denote as a O. If you see here clearly, big O annotation we have denoted as a O. If you see big omega annotations, so this is the omega symbol we are denoting. Theta symbols, so based on the theta symbols also we can decide our time complexity. This is the three measurement you can say. But the problem is, if you go with the big O, okay, the problem is if you go with the big O, for example, big O, this is the big O only. So big O will calculate only the time which is worst case, worst scenario or case. The high, how much high, what is the maximum upper limit, what is the max worst case will happen, big O annotations will denote. That is called, this is the big O. We are saying sometimes big O of n, big O of 2n, like that. I hope you have already listened like that. So this is calculating the time complexity as a worst case. If you go and if you say big O of omega, okay, so it will calculate the average case, average case. So in average case it will work. So for that we have to write like that symbol, and then we have to write n. If you are calculating any time complexity in theta notations, so if I talk about big theta, then that is called lower case. So in lower case we can calculate with theta also, like order of n. But if you think about, if you go with the any competitions, so people will not ask you what is the lower, okay, let me change my colors. So the interviewer will not ask you, hey, what is the lower average, or what is the leverage, what is the lower of this, what is the high average of this. People will only ask what is the worst scenario, okay, in which case it will take more time, what is the maximum time it will take in any platform. It's not depend on a platforms, what platform we are using, what we are using, does not matter, it does not matter. So peoples are always going to follow only and only big O annotations, big O, and we are calculating the all those time complexity in worst case, high, maximum time taken. How much it will take. So this is the last one, big O of annotations, okay. So after that it will not give more than that, that is the end, right? So we are not going to calculate the time complexity in average case, we are not calculate the time complexity in lower case also, but people will ask you the worst case, and in the most of the time you have to tell what is the worst case. Worst case means what is the maximum time complexity, not minimum, upper limit time complexity, okay. And that is very important to tell what is the upper, because lower is not required for us, average is not required for us, we need the maximum time, how much maximum time it will take. That is very important things. For example, so we don't want to consider any theta or omega, we have to just consider which one, big O. big O annotations. We are writing like that. Big O. Big O annotations. Okay. So what we can do is, for example, in the big O annotations, if you have any array and we are iterating, for example, we have a one array and array size is 5. Okay. And if you use any loop to iterate up to 5 times, so this one we can calculate as a order of n times complexity. Okay, this is the order of n time complexity. Let me explain you in the depth. Okay, so let me go here. For example, we have these questions. Okay, we have one example here. So this is the array we have. Okay, so this is the input array, and here we have taken one more some variables, and we are calling the sum method while passing a array or 4. What will happen once you pass this value here? What we are doing? We are taking those value and we are creating one variable. So that is a space complexity. That is not a time complexity. We'll consider that is called a space complexity here. Okay, but time complexity will consider only one, like how much time it will take the execution. So for example, for executing this line, it will take order of n, order of not n, 1, order of 1. For this loop, if you see, it's going up to array. So what is the length of this? Just assume the length of the array is n. Then it will iterate one by one up to n times. So it means that this statement inside this available of the for loop, it will execute order of n times. Order of n times. So if it is execute order of n times, so time complexity is order of n. So if you calculate this method time complexity of this method, then we can say order of 1, okay, plus order of 2. Order of 2 means order of n. So here we can write order of n. Let me write order of n. So once you write order of n, and if you calculate it, what it will become? We can neglect it. Why we can neglect it? Because we have a n, and in the n, if you add any one value, that is not impact. Okay, that is not impact. So if it is not impact, then we can ignore it and we can just calculate order of n. So this method execution or time complexity is order of n. Okay. If you tell me to ask like what is the space complexity, so space complexity is also here, it's a constant space complexity. Okay, so they have taken n number of the arrays, so space complexity is also order of n only. Okay, that is clear. So like that we are considering the time complexity and space complexity in our code. Okay, let me give you some more example. Okay, for example, we have some code. For example, we have a one method called public static void. We don't want to worry about any methods. Okay, method name, method signatures, those we have to ignore it. Okay, and inside the method block we have a one for loop. Okay, and inside the for loop we have written some of the statement which is 0, it will go up to n and I plus plus. Okay, and inside this loop we have a one more loop. Okay, int j equal to 0, j less than n, and j plus plus, open close, having some statement here. having some statement here based on the requirement. Okay, so what will happen is, what is the time complexity of this method to execute? So time complexity of this method is, what is the time complexity? If you consider it, the time complexity is order of n square. Why n square? Because this will execute one times, correct? This will execute the one times and this will execute the, so if it is, this one is executed one times, if this one is executed one times, for one times it will execute n times. So for 1n, 2n, 3n, 4n, so if you calculate all those n, what will happen? So this is also n time, and for 1 it will iterated the nth time. So what will happen? N multiply n equal to n square. So that is the time complexity of, if you use two loops like that, so it will consider as a order of n square. So almostly if you see the time complexity, we are generally considering as a loop. Okay, and if you talk about the space complexity, so there is no space we have taken extra here. Okay, if you see here, there is no extra space we have taken. So if you say a space complexity, then I will tell order of 1, because we can't consider as a input whatever the we have given, but for solving this particular problems we have not taken the extra space. That's why we can say like space complexity is order of 1. Okay, otherwise we can say order of 0 also. Here there is no variable we have created, correct? Yeah, correct. Okay, go down, let me explain some more about it. Okay, for example, we have some scenario like we have a class A open close. If someone asks you like what is the time complexity, nothing, we can't consider for that. So only time complexity we are calculating based on the loop and number of statement. For example, we have a one loop. This is the for loop, okay, open close, and one more for loop we have, okay, and this is the body of having. If you tell me like what is the time complexity for that, so I can say this one will execute n times, so order n plus order of n. If you add it to n, so order of 2n. The time complexity is order of 2n, so we can consider as a order of n only. Okay, because we can neglect order of constant value. So in the constant value we can neglect almostly, so not required to add those constant value. Okay, second point is don't add while calculating the time complexity or a space complexity, don't add constant value, because if you add any constant value it will become constant only, whatever if you give. So not required to give the calculate the constant value. That is also one principles you can remember it. Okay, also one more things, for example, sometimes whatever the extra space, if you take extra space for solve any problem, then that space is auxiliary space. Auxiliary space we consider. Okay, that is the auxiliary space is not required. So even you are taking any auxiliary space, try to avoid it. Try to avoid it. Try to avoid it, because if you take the auxiliary space, that is not good practice. So if it is not avoid, that is fine, but if you are able to avoid it. Don't take any extra things. Try to solve any problems. Okay, the third point is like this is the second point, so this is the third point. So third point is always focus on loop execution. Okay, try to minimize loop execution time so that you can go order of n log n time complexity also. So if you minimize as much as possible of the time complexity through the loop, then you are going inside this, the what we can say, that is called a we are reducing the space or we are reducing the time, so then we can go with the log. Okay, so log is also very good concept to calculating the time complexity. Okay, for calculating the space complexity, so for example, if you take any array to solve any particular problems, okay, and you created new int n size of array, so this is the auxiliary space, or we can say space complexity also. And here the space complexity is order of n. Like that we can calculate it. If you create any integer variable, int a equal to 20, so for that we can say time complexity or space complexity is, so a space complexity we can say like order of 1, that is called constant value, constant iteration. Okay, so I hope you understood what is the time complexity, what is the space complexity, and how we can calculate it. Let me show you one more example here. So for example, this is the code I have. Okay, so let me go inside this method. Okay, so if you see this code, which is a string, okay, so here if you see this method will take in what is the time complexity, so only one constant time complexity. So we can say the time complexity is, now I am going to give t or c, that is called time complexity, with order of n, order of 1 here for this method. If you see order of 1, but if you talk about this method, so this method will take the time complexity is order of n, because it's taking the help of the loop, one loop. It is the time complexity. Apart from whatever the method we have, that is called order of 1. And here if you calculate, here if you also say, so there is no space complexity, so order of 0. So if you say space complexity order of 0 here, there is no extra. 0 means this one only it will print. Okay, so this is the 0, order of 0. But if you talk about any loop related or any extra array or array list if you are taking, then that time we can say the space complexity is that much. Generally, I have seen the people are asking the space complexity, and they will ask to optimize it, space complexity or time complexity. So you have to be careful regarding that. Okay, thank you so much.